This is Unit 6, Lesson 10, Different Ways to Solve One Equation. And our focus question is, what is the most efficient way to solve an equation with parentheses? So let's look at 10.1, solving each of these equations. So if I look at this first one, I have 100 times the quantity x minus 3 is equal to 1,000. So if I have 100 x minus 3's, if I divide that by 100, I'll end up with just 1 x minus 3. And I have to do the same thing to this side. 1,000 divided by 100 is 10. And now here, if I want to get x by itself, I have x minus 3, so I would add 3 to both sides. And I end up with x is equal to 13. Another way I could solve this would be to use the distributive property first. So I distribute this 100 to x minus 3. 100 times x is 100x. 100 times 3 is 300. Now to get the x's by themselves, I would add 300 to both sides. So I'd end up with 100x is equal to 1,300. Then I would divide the x's by 100, and divide this side by 100, and I end up with x is equal to 13. So I could see we get the same answer. So I'm not going to do every one, but I want to look at this one next, and then this one. So let's look at this one here. 0.03 times the quantity x minus 3 is equal to 0.3. So I'm going to use the distributive property first. 0.03 times x is 0.03x minus 0.03 times 3. I'm just going to pop out over here. 0.03 times 3 is 0.09 is equal to 0.3. Now I want to get the x's by themselves, so I'm going to add, since I'm subtracting 0.09, I'm going to add 0.09 to both sides. So I end up with 0.03x is equal to 0.39. Now I would divide by 0.03 and divide by 0.03. So I have x is equal to 0.39 divided by 0.03. Put my decimal there. 3 goes into 3 one time. 9. 3 goes into 9 3 times. So I end up with x is equal to 13. So now I'm going to do that using division instead of the distributive property. So I start out with 0.03 times the quantity x minus 3 is equal to 0.3. So instead of using the distributive property, I'm just going to divide this by whatever I'm multiplying by. So divided by 0.03. I'm going to divide this by 0.03. So I end up with x minus 3 is equal to 0.3 divided by 0.03. 0.3 divided by 0.03. So I'm going to move this decimal place over twice. So I'm going to move this one over twice. So 3 goes into 30 10 times. Now I'm going to add 3, and I end up with x is equal to 13. Same answer. So let's go down to the last one. The last one says 1/7 times the quantity x plus 2 is equal to 10/7. So I'm just going to use division on this one. I'm going to divide this by 1/7. And if we take a fraction and divide it by another fraction, or if we're dividing by a fraction, we're really just multiplying times the reciprocal, right? If we take 10 over 7 divided by 1/7, when we divide by a fraction, we need to multiply by the reciprocal. So this would turn into 10/7 times 7 over 1. So what I'm going to do here, instead of doing all this work here, converting, I'm just going to go straight to this. If I'm going to divide by a fraction, what I'm really doing is multiplying by the reciprocal. So that's what I'm going to do. I'm going to multiply each side by 7 over 1. So now I end up with x plus 2 is equal to 10 times 7 is 70. 7 times 1 is 7. 70 divided by 7 is 10. So what I have here is x plus 2 is equal to 10. So I'm going to subtract 2 and subtract 2. And I end up with x is equal to 8. And I could use the distributive property here. I could multiply 1/7 times x plus 1/7 times 2, which would give me 2/7, right? Is equal to 10 over 7. And then I could solve that way. Subtract 2/7 from both sides. And I would still end up with x is equal to 8. So let's look at 10.2. 3 students each attempted to solve the equation 2 times the quantity of x minus 9 is equal to 10. But they got different solutions. So here are their methods. We have Noah's method, Elena's method, and Andre's method. So we're going to go these one by one and analyze what they did. So let's see what Noah did first. Noah, since he was thinking since you're subtracting 9, he's going to add 9 to both sides. So 10 plus 9 is 19, so that looks good. But then over here we have 2 times the quantity of x minus 9 plus 9. If we have 2 times the quantity of x minus 9, and we add 9 to this, we don't know what x is, so we can't say that this is 2 times the quantity of x, 2x. Since this is in this parentheses, we can't just add 9 here. And that's a common mistake. That's a common thing you're going to see. So we can see that when he did this step here, this adding 9 to both sides, since this was in the parentheses, you can't do that. And just to be sure, we can put a number in here for x. Let's say we have a 2. Let's put a 2 in for x. 2 minus 9 is 7. Negative 7, sorry. Negative 7 plus 9. Negative 7 plus 9 is 2. 2 times 2 is 4. 4 plus 9 is 13. And 13 does not equal 10 plus 9. There probably is some number, but it won't work with every number. So let's look at Elena's method. So what Elena did is she used the distributive property first, 2 times the quantity of x minus 9. So she did 2 times x to get 2x minus 2 times 9 is 18. So that looks okay. Then she did 2 times x minus 18 minus another 18. But she only got 2x. If you have 2x minus 18, then you subtract another 18, that should be negative 36. So that's a common mistake too. If she's subtracting 18, what she should have done was add 18. She should have added 18 to 10. So let's look at Andre's method. So Andre started out like Elena. He used the distributive property. 2 times x is 2x. 2 times 9 is 18. Equals 10. So that looks good. And then here's what Andre did. He did add 18 to both sides. So 2x minus 18 plus 18 would be 0, so he just ends up with 2x. 10 plus 18 is 28. Then Andre divided each side by 2. Since he's multiplying x by 2, he divided by 2 and got x. 28 divided by 2 is 14. So it looks like Andre did this problem correctly. So some things you want to watch out for is if you subtract 18, you want to add 18. Or subtract a number, you want to add the number. You want to do the opposite so that you cancel that out and you end up with just the x's. And you want to do that to both sides. And another thing to watch out for when Noah's method, if the subtraction is inside parentheses, you cannot just add 9 to both sides. Or whatever that number is. Or even if it's addition, you can't subtract 9 from both sides if it's inside the parentheses. All right. So 10.3 says for each equation, try to solve the equation using each method, dividing each side first or applying the distributive property first. So the two methods we're going to use are dividing and distributive property. Some equations are easier to solve by one method than the other. When that is the case, stop doing the harder method and write down the reason you stopped. Okay, let's do this one. So we're going to start out with 2,000 times the quantity x minus 0.03 equals 6,000. So this one I'm going to divide by 2,000. So I end up with x minus 0.03 is equal to, oops, I'm going to divide by 2,000, divide this side by 2,000, is equal to 3. Then I'm going to add 0.03 and add 0.03, and I end up with x is equal to 3.03. That was pretty easy. Let's use the distributive property and see how easy that one is. 2,000 times the quantity x minus 0.03 is equal to 6,000. So 2,000 x, and use the distributive property, 2,000 times x is 2,000x minus 2,000 times 0.03 I get 0.006 60 minus 60 is equal to, I can already see this one is taking a lot longer. Now I'm going to add 60. I'm going to add 60. So we end up with 2,000x is equal to 6,060. Now if I were to divide this, I'm not going to do it. I'm going to stop here. I'm going to do what the directions say. This is taking quite a bit longer because I have to multiply these decimals times these big numbers, and I have to, this division doesn't go into this very easily. So I'd end up doing a big long division problem. Or if you have a calculator, we could just calculate it, right? 6,060 divided by 2,000 is equal to 3.03, which is what our answer is here. Okay, let's look at the next one. Two times the quantity x plus 1.25 equals 3.5. So I'm going to use my division here and divide by 2 and divide by 2, and I end up with x plus 1.25 is equal to, so this isn't very nice, is it? 3.5 divided by 2. I'm going to have to, I'm just going to get my calculator out now because this is getting a little hard. 3.5 divided by 2 is 1.75. Now I do my addition or subtraction here. Minus 1.25 minus 1.25, and I end up with x is equal to 0.5. But let's try it the other way. Let's see if the distributive property would be easier in this case. 2 times the quantity x plus 1.25 is equal to 3.5. So I'm going to distribute this. 2x plus 2 times 1.25, that's pretty easy. That is 2.5 is equal to 3.5. Now I'm going to subtract 2.5, subtract 2.5. So 2x is equal to 3.5 minus 2.5 is 1. Divide by 2, divide by 2. X is equal to 1 divided by 2 is 1/2, or 0.5. So I get the same answer, only this time I didn't have to get out my calculator at all, did I? I was able to do that all without a calculator. So number 3. One-fourth times the quantity 4 plus x equals 4/3. So I'm going to use my division here. I'm going to divide by 1/4, but remember when I divide by a fraction, if I divide by 1/4, I'm really multiplying by the reciprocal. So I'm going to multiply by 4/1 here. So now I end up with 4 plus x is equal to 16/3. So I'm going to subtract 4 and subtract 4. 16/3, I'm going to change that into a mixed number. 3 goes into 16, 5 with 1 left over, so this was 5 and 1/3, minus 4. X is equal to 1 and 1/3. Okay, that was pretty simple without a calculator. So let's use the distributive property now. So 1/4 times 4 is 1. 1/4 times x is 1/4 x. Now, or 1 and 1/3. Now I'm going to subtract 1. I'm going to subtract 1. So I have 1/4 x is equal to 1/3. So now I need to divide by 1/4 or multiply by 4/1. So I end up with x is equal to 4/3. I think both of those were pretty easy. 4/3 is the same as 1 and 1/3, which I got here. All right, let's do the last one. So negative 10 times the quantity x minus 1.7 equals negative 3. So I'm going to divide by negative 10, divide by negative 10. So I end up with x minus 1.7 is equal to 3/10, or since I have a decimal over here, 0.3. So now I add 1.7. Since I'm subtracting, I'm going to add 1.7, and I end up with 2. So x is equal to 2. That was pretty easy. Let's use the distributive property and see if that's going to be even easier. Negative 10 times the quantity x minus 1.7 is equal to negative 3. So negative 10 times x is negative 10x. Negative 10 times negative 1.7 is positive 17. Okay. Now I'm going to add 17, or sorry, subtract 17, right? Subtract, so since I'm adding 17, I'm going to subtract 17. So negative 10x is equal to negative 20. I'm going to divide by negative 10, divide by negative 10, and x is equal to 2. So I get the same answer. I think both of those were pretty easy. Sometimes it's going to be your personal preference, right? Which method do you want to use? Do you want to use division, or do you want to use distributive property first if you have parentheses? So some of these, like these up here, if you're dealing with some nice numbers you can divide by, 2,000 divided, or 6,000 divided by 2,000, that might be easier just to do the division and you get a nice small number here. And sometimes it's not going to matter. Okay, what are the two ways to solve equations involving parentheses? 1, you could use the distributive property. Distribute that number outside the parentheses. 3 times x is 3x. 3 times 2 is 6. And then solve using your inverse operations. The other way to start out is to divide each side of the equation by the number next to the parentheses. So whatever number you're multiplying by here, that's the number you divide. So if we have 2 groups of x, or 3 groups of x minus 2, if we divide that by 3, and what we do to one side we do to the other side, we just end up with what's inside the parentheses. X minus 2, and then 36 divided by 3 is 12. And then we continue to solve using inverse operations, but you can see we come up with the same answer. And how can you check if your solution is correct? Well, you can put your answer back in, replace the variable with your answer. So in this case, our answer was 14. So we're going to put 14 in for x. So 14 minus 2 is 12. 3 times 12 is 36. And 36 is equal to 36. So we know we did that correctly.